So, all right, now let me introduce our next special guest speaker, Professor Iryna Gurevych. Iryna is a professor and director of the Ubiquitous Knowledge Processing Lab at the Technical University of Darmstadt in Germany. She is also an adjunct professor at MBZ University of AI in Abu Dhabi and an affiliated professor at Insight Institute in Sofia, Bulgaria. So Iryna has been working on natural language processing, and her work has been awarded numerous times, including the ACL Fellow Award and many others. So last year, she served as the president of the Association for Computational Linguistics, which is the most influential organization in the NLP field. We are especially grateful that she is joining us online today, despite the time difference between Germany and Japan. I believe that in Germany it's currently 7 a.m. And there's much more to say, but I cannot wait for her talk. So without further ado, let's welcome Professor Iryna Gurevych. Okay, take it away.
Yeah, thank you very much for your kind introduction and welcome to my talk. My best greetings from Germany, Frankfurt to Japan now. My talk is about a project called Intertext, which is a large-scale grant from the European Commission. And here we work on cross-document NLP. Specifically, a lot of work, as we all perfectly know, is text work, especially now with the introduction of large language models. We do a lot based on large amounts of text. And also, as we know, humans are not good at all at handling a lot of text. Humans are excellent to achieve deep understanding of a small amount of text because we have a lot of background knowledge, context, and common sense. However, if we deal with a huge amount of text, our memory and attention are very limited, and reading a long document is very hard for a human, and even more hard it's to navigate a collection of documents and understand the relations across documents. Now, in the past decades, some things got much, much easier thanks to developments in AI and NLP. We now have good search engines, good recommendations, and information extraction. Machine translation works quite well, sometimes amazingly well, especially between well-known languages. And recently, we got new human-like chatbot interfaces like ChatGPT and similar large language models. And as we know, most of these applications are powered by transformer architecture, which many people in the audience, I assume, will be familiar with. However, despite all of this progress, some things are still very hard. For example, AI cannot help us to find reliably where a specific piece of information comes from. We still have very few tools to judge the information quality. And with the rise of LLMs, this question is becoming of a paramount importance. AI for reading assistance is very, very limited, and there is not much AI assistance for collaborative writing, which is becoming ever more popular. And though we have convenient tools like Google Docs or Overleaf, they are to some extent still at the level of paper and pencil in terms of AI support. Why is that? When you think about a lot of text, you probably think about a long book or a pile of documents. This text is static. But a revision history of a single document or a chain of related texts and references are also a lot of text. And this is what we call living text in context. So this is a very, very complex phenomenon because texts are not static. Texts emerge, that is, they have a history moving over time, and also texts emerge in a specific context. They are related to other texts. And as I've just explained, humans are quite bad at handling this text in context. So the project that we have, which is called Intertext, is a framework to model text as a living object in context. We call this the Intertext Initiative. And here we build on so-called intertextuality theories from literary sciences and from the humanities that look at text as a living object in context. So now think about the Bible, for example. So people have studied that many hundreds of years ago. And in the humanities, people have developed theories of how texts change over time and how texts are related to other texts. So we borrow this theoretical foundation, and we propose to see each text along two dimensions, time and context. When a text is updated, it moves through time. When another text talks about the text, it moves through context by reference. And in Intertext, we develop new conceptual models, design tasks, and create methods and data sets to analyze fine-grained relations between texts in time and in context. This is our research team funded by several projects, including a 5-year grant from the European Research Council, which started in April last year, so about a year ago. So it's quite a new project. And we continuously report our progress and new results on our website, which you're welcome to visit. And in this talk, I will cover just some parts of our work, as well as some other related studies in our lab. And most of our work in Intertext right now is around academic publishing and peer review. The reason for this is that this case study is particularly well suited to analyze cross-document relations. Scientific documents are a great research target. You have long documents connected by citations, often in multiple versions. However, published documents are just the tip of the iceberg. Most scientific publications go through peer review, and when you submit a paper, a reviewer would give you feedback, then you revise the paper and resubmit it until it's good to be published. This, of course, generates a lot of interesting data. This data is great for our intertextual cross-document analysis because it has texts in context that evolve over time. And all of this usually happens within a reviewing platform, so all of the data is in one place and easier to collect. Peer review and academic writing have many challenges, and NLP for peer review is a growing area right now, to which we contribute new tasks, methods, and data sets. So in my talk, I will focus on 3 points. So the first, I will present some of the data sets that we have collected in this domain and the tasks that we propose to be solved or addressed based on this data. Then I will focus some work that we do in the area of text generation based on scientific data set corpora. And last, I will present some ongoing projects very briefly. Now we start with the data sets, which is a foundation of any new research area. It turns out that getting a data set is quite difficult because we need data sets that are clear with respect to ethics, licensing, and GDPR, that is personal information clearance. And well, earlier I mentioned this notion of NLP for static texts and NLP for living texts in context. It is already very hard to collect clean data even for static texts. Despite the fact that static texts often come from just one source and one group of authors and have some licensing standards, and also some reasonable defaults. That is already quite hard. But if we want to collect data for our cross-document corpora, that is for living text in context, we run into new document types that historically have been a gray zone. Now, what new questions emerge, like what is the license of a paper draft, or how to attribute the author of a blind peer review, how to prevent information leaks through context. For example, if we publish a review of the paper which has not been yet accepted, we may leak some confidential information related to new research ideas. And these are important questions that determine if the data can be used by the research community. So peer review is a very good example of such a complex data acquisition situation. And in NLP, people have dealt with it in 3 different ways. The first approach is just to take the data from some public peer reviewing platforms like OpenReview. This started the whole research direction of NLP and AI for peer review. However, it is very problematic in all other ways because we don't have the consent of the authors to use the data for research purposes. And OpenReview has put no license on peer reviews, and also authors and reviewers have not given their consent. The second way is to look for open sources on the internet, and indeed there are some fully open reviewing platforms that publish papers, reviews and revisions, and even reviewer names. However, this data is quite scarce, and most research communities and top-level venues do not like it. Now, the third hard way is to set up a data donation workflow. One can go to any conference and ask them to implement a workflow where reviewers and authors give consent and transfer license for their data. And later we can collect and publish this data. This is the most flexible and most ethical and legally compliant way, of course, but it is also the hardest way. And in our work, we introduce this so-called yes, yes, yes donation workflow, which is a general purpose data collection workflow for peer reviews. We first ask the reviewers if they want to donate their data, and if not, we stop the process. If yes, we ask the authors and wait for the paper to be accepted, and only if all 3 conditions are met, it is safe to collect this data point, including the reviews. This is a very carefully designed workflow with consent forms, license templates, and open source implementation. Everything is available to be reused. And we publish a paper about it where we studied how donation-based data collection affects the data. And in particular, as you can easily see, we have a strong bias towards papers which received high scores in the conference. Currently, this data donation workflow is implemented in the ACL rolling review platform called ARR. So if you stumble upon a data donation request, this is us, and please consider contributing your data. The research community will be thankful for it. To this point, we have collected 2 major sources of papers. Peer reviews and revisions to help study cross-document relations in peer review. And the first corpus is F1000RD, which is a collection of papers, revisions and reviews from the open platform called F1000 Research, where researchers from different disciplines can publish their papers, revisions, and reviews. This corpus is fairly large, and it has papers and reviews and around 500,000 words in total. We have published this corpus along with some software that makes it easier to work with the documents included in the corpus. And this is a first-of-a-kind resource to study text as a living object in context. which is supplied with an open license. The corpus has 3 annotation layers corresponding to tasks. They are linking, versioning, and pragmatic tagging. Our first task is linking. Given a document A that talks about document B, we want to find anchors in document A and link them to targets in document B. First paragraph of section 3 is an explicit link, and the use of mosquito traps is an implicit link. So there are explicit and implicit links, and the task might sound familiar from other related tasks like citation span detection, plagiarism detection, and evidence detection and fact-checking. So linking that we present is a generalization over those tasks in a general task definition. Our second task is versioning. In versioning, given 2 revisions, A1 and A2, we want to find edits and label them. This might sound familiar from related work in Wikipedia edit analysis and student essay revisions. Versioning is a more general form of these tasks. We distinguish between 2 kinds of revisions. Short scope revisions are minor edits, usually with one intention like a paraphrase. And long scope revisions are much more challenging because they are major edits that will include many complex intentions up to a complete document rewrite. And in many real-world scenarios, we actually deal with long scope revisions, while NLP so far has mostly focused on short scope revisions, which makes this area of research very novel. And last, we have also presented the task of pragmatic tagging because a peer review has a job, so it has an intention. Here we label the sentences in reviews with general pragmatic tags like recap, weakness, strength, to do, and other. And recently we have run a shared task on low resource multi-domain pragmatic tagging of peer reviews in an EMNLP workshop. Based on this F1000 corpus, we have implemented some pilot studies published in a computational linguistic articles where we look at answering complex questions with the help of our intertextual model. For example, what is the intention of this sentence? What is it about? And what change did it cause in the paper? Or what parts of papers receive most criticism? And which types of comments trigger most change? So all of these questions can be answered, powered by our intertextual graph. That is a novel document representation, which we present in that article and which preserves document structure and multimodal elements like tables and figures. So next I present another novel data source, which is called NLPeer. NLPeer is a major resource, which is very new for peer review. And here we have combined openly available and donation-based reviewing data from our workflow, which I have initially introduced to create a one-stop shop for the computational study of peer reviews. It's a massive resource that covers over 5,000 papers and 11,000 peer reviews with 4 million words in reviews alone. It combines ethically sourced data from different research communities and reviewing systems in a unified format. And it is also coupled with several practical reviewing assistance tasks, some of which make use of cross-document relations and other are more applied, like score prediction and pragmatic tagging. To be more specific, in NLP, we collect 2 entirely new corpora from the computational linguistics domain, and we crawled and parsed a new batch of F1000 reviews that I've just presented as well. So that makes NLPeer not only the largest easily accessible corpus for peer reviewing research, but also it covers different domains beyond NLP and computer science, and also both closed and open reviewing paradigms. This is quite essential while peer review is used everywhere in the academic world, it is used in different styles. So there are many variations of peer reviewing, and the resulting peer reviews may differ widely in their properties. So we need to study how to effectively transfer methods between scientific domains and reviewing approaches to make them truly impactful. So imagine, for example, we can train our models on large open peer reviewing data sets, and then we can transfer them easily to the data scarce close reviewing scenarios. In NLP, we investigate several applied tasks to actually assist the junior reviewers. And in the guided skimming for peer review tasks, we showcase the practical use of intertextuality. In particular, we use the explicit links in peer reviews pointing to regions in the paper as a signal for supervised learning. I give a couple of details about this. In this scenario, as I said, we want to help a junior reviewer during their multiple repeated reading of the paper to suggest certain regions of the paper that require the highest attention. We first extract explicit links from reviews to the paper. The anchor paragraphs of those links are considered as relevant or review-worthy. And this way, we create binary labels that are used during training and evaluation. We train a simple Sideburd model by sampling relevant and irrelevant paragraphs of the paper and fine-tuning the model via contrastive examples. The resulting model is a regression model that predicts the relevance of each paragraph in a paper and ranks the paragraphs accordingly. We apply this model to unseen papers and generate a relevance ranking of the paper paragraphs. And on the right, you can see that the Sideburd model outperforms the random baseline by a large margin. So in fact, it is possible to predict the linked passages of a paper which are review-worthy. And we also show that the targets of explicit links can serve as interesting training signal, which correlates with certain linguistic features in the paper. Now I move to the second part of my talk, where I want to present some works that we have done in this domain on text generation for the scientific discourse. In particular, we will look at two problems that we have been working on to assist the authors. The first is rebuttal generation, and the second is related work generation. We start with rebuttals, and rebuttals, as you know, are author responses to their reviews. This work has been published very recently in EMNLP 23. Rebuttal is a key component of peer review, in particular in the domain of AI and NLP. We now have this as standard part of the reviewing process. And the goal of a rebuttal is to convince the reviewers and correct misconceptions about the paper. Rebuttal writing is a very hard task, especially for junior reviewers, because for this, they need to extract the main points of criticism from the reviews, and also they need to formulate convincing counter arguments. This is particularly hard for very subjective evaluations of the paper, where reviewers' background and general views play an important role. So the reviewers might already have some preset attitude. Now the question is, how can you effectively convince a reviewer with such a preset attitude? Actually, this problem is not specific to rebuttal writing, but to argumentation in general. This is about the question, how can we convince people with preset attitudes in general? And one strategy that proved successful in other contexts and also has some psychological evidence is the so-called jiu-jitsu argumentation. The main idea, as in jiu-jitsu, is to convince your opponent by using their own strength. In other words, you want to transform their original argument into a direct counter-attack, which involves their underlying values. To give you an example, we have had a study with psychologists in 21, when the corona pandemic was heavily discussed on social media, and people presented such arguments like, in the end, more children will die from side effects of the pandemic rather than the virus. So these are anti-vaccination arguments. And in jiu-jitsu argumentation, we first identified the underlying attitude root. Here, this is a general fear of death, and the so-called theme here, side effect. And based on this classification, we come up with a canonical rebuttal. So a rebuttal that works independent of the specific phrasing and that attacks the initial argument at the attitude root and the theme. So for example, if here the attitude root is fear of death, we can formulate a canonical counter argument that even more people will die if no vaccination is performed at all. And this way we have a chance to convince our opponent. So for our work here, we apply this technique to the case of rebuttal generation in scholarly publishing. And we propose a new data set called JitsuPeer, consisting of over 2,000 reviews annotated with attitude roots and themes, along with 3,000 canonical rebuttals. So now, if we can assign a review sentence to a cluster of attitude, root, and theme, we can address that review sentence with a corresponding canonical rebuttal. And the canonical rebuttals also have different rebuttal actions. For example, mitigate criticism, which provides flexibility of use in different contexts. We propose 3 downstream tasks to assist junior researchers along with multiple baseline models. The data set was made in multiple steps, but I only cover 3 main steps here. Given a review with multiple review sentences, we first identify attitude root for each review sentence. We use the ACL peer review aspects as the attitude roots here. And in step 2, we enrich the identified attitude root with a theme. We use the review paper section link here. For example, the review sentence talks about the overall writing of the paper. And finally, in the last step, we generate descriptions for each attitude root theme cluster, and then we retrieve the best canonical rebuttal for that cluster using preference learning techniques. To assist authors in rebuttal writing, we propose the novel task of canonical rebuttal generation. The task involves generating a canonical rebuttal given a review statement and a rebuttal action. We experiment with a large number of models and observe that all models reach a plateau after some point, for example, after 2 examples given, and fail to generalize well. This can be attributed to a very big variety of rebuttals in the data set, which is difficult to memorize for the model. Now let's look at the second work of related work generation, also published recently in EMNLP 23. Research builds upon prior knowledge, and the amount of prior knowledge is constantly increasing. This motivates the task of automated related work analysis that can help reduce time and effort required to provide a related work section, and also increase the research quality in general by calibrating this section of the work. Citation text generation is a task which has been previously introduced and which aims at generating a passage of text based on information about the citing paper, like title, abstract, content, and the context before and after the citation, and the information on the cited papers represented, for example, by the title, abstract, or specific content. The task has been previously widely studied in NLP, but so far it lacks a unified task definition and benchmark, so it is hard to compare citation text generation systems across each other. Our work presents a new benchmark that we called side bench. So we built this benchmark to address the described problem. And this is a first unified benchmark for citation text generation. We have included several unified data sets under a unified task definition. And we have presented a large number of standardized baselines and evaluation metric. I briefly summarize the results of this study for you. We have used this data to study how well popular baselines and pre-trained models perform on different data sets and task formulations. On the top, we have extractive baselines, which are very old. Lead selects three first sentences from the input. So TextRank and LexRank are graph-based unsupervised models for extractive text summarization, and we used existing implementations for that. In the middle, we have abstractive baselines built with pre-trained language models. We needed models that support long inputs, and since the study was done a while ago, we used several variants of LED, the reference long text transformer at the time. We have two variations of the model, base and large, and also a version which was pre-trained on archive papers. And finally, we experimented with supervised models that we fine-tuned on a mixed training split from our benchmark. We evaluated everything using two metrics, Rouge and the BERT score. And as you can see, supervised models perform best, but extractive baselines also perform surprisingly well. And interestingly, the smaller LED-based model often performs on par with a large model for the same task. We also note that the two metrics, BERT and Rouge, are highly correlated. So higher Rouge almost always pairs with a higher BERT score in this task. So fine-tuned supervised models performed best in terms of scores, but we also wanted to get some qualitative insights. Are there some systematic qualitative differences between generated texts and original human-written texts? Since checking this manually would be very hard, we used two discourse tagging models from previous work to predict citation type and citation intent. And then we compared the distributions between generated texts and reference and found that generated texts follow a different discourse structure. For example, in the figure, we can see that the baseline models on the top generated a lot of reflection and other sentences, while under-generating narrative citations and single paper summaries. Yet supervised, fine-tuned models generate those, and this is in line with the actual reference text from the test set, which you can see on the bottom. Overall, this project made us ask what information is in fact needed to generate accurate citation texts. A commonplace approach is to feed the model paper abstracts and citing context, but this might not be enough. So we are currently investigating what information is needed to generate citation text effectively, and we are running some experiments with large language models for prompting them for citation text generation. Now I move to the outlook and some of our ongoing work that I would like to briefly characterize. I mentioned the linking task in the beginning of my talk when we talked about our F1000 RD corpus. And there are two kinds of links, explicit and implicit. Explicit links are something like section 3 or first paragraph. And as I mentioned, finding them is quite easy. We can use those links as a training signal for various cross-document tasks. But of course, implicit links are much harder to work with. There are two challenges, subjectivity and cross-domain variability. And currently, together with Tom Hope from the Jerusalem University and LangAI, we develop different approaches to address the task of implicit linking. The first approach is taxonomy-based. Here we classify sentences based on a shared taxonomy of the target document and match and link similar cases, for example, methods to methods. And the other approach is LLM-assisted retrieve and re-rank approach. Here we retrieve semantically similar sentences and we rank them using LLMs after injecting a notion of relevancy in the process. Our second ongoing work, again with Tom Hope from LangAI and University of Jerusalem, is on analyzing scientific discourse over time. So this is something that we term science of science. So it's a meta-science study where we use some temporal graphs. In particular, we model citations between papers and as multi-party citation dialogue temporal graphs. And we want to understand what can we predict from who is talking to whom about what over time. For example, we can predict future scientific dialogue. That is the next citation phrase that is going to happen, or we can predict and quantify the impact of papers from how the paper has been discussed in literature. Next, we have a work ongoing together with MBZ, with Preslav Nakov and Osama Atzval, who is our master student, together with some other researchers as Tom Hope and Xiaodan Zhu from Queen's University in Canada. Here we extract novel claims from a scientific work, and we verify these novel claims by analyzing both the cited literature and other relevant research in the same domain. We want to create a delta score to quantify how much the presented work differs from the existing state of the art. This is the novelty assessment task. And also we want to provide an explanation why the work is considered novel or not, and to what extent it contributes to the field exactly. And finally, the last project I'd like to mention is Human AI Collaborative Writing. This project is quite in the beginning. So here, collaborative writing is just one task from a more general paradigm of human AI collaboration. And as we know, writing and editing texts are particularly complex processes, which are in demand of a lot of training and intellectual efforts. And in this work, we claim that LLMs and humans have complementary strengths. So we want to create models of how humans write and revise texts and investigate how AI and LLMs can help making this process more efficient by intelligent task distribution and composition of collaborating human and AI. This brings me to a summary of my talk. Just to recap, in this talk, we discussed a new approach of intertextual NLP, which looks at text as a living object in context, moving through time and other documents. And as our working walkthrough example, we used peer review from the scientific domain. As you can see, this is a large and interconnected problem space with many research directions and many challenges, some of which our lab has addressed, in particular creating new data sets, work in scientific argumentation, scientific text generation, and science of science. And we have created many reusable resources, in particular very valuable data sets, which are novel and can be used by anybody under safe, legal, and ethical conditions. And in the end, I also presented some example work by our lab in the domain of text generation related to rebuttal generation and related work generation. And also we have a bunch of projects ongoing right now that you can hopefully find in future on our website if you are interested to follow our work. Thank you very much for your attention, and I'm very much looking forward to your questions and the general discussion of this topic. Thank Thank you.
Thank you, Iryna. Okay, let's take some questions from the audience. If you have any questions, please show your hands, or we can also take questions from YouTube. If you have any questions, please comment. Nope. So can I start a question from myself? Thank you for the talk. It was really interesting to me. So I was, I've been very interested in how review system is, getting very, not bad. I mean, it's really difficult. I mean, there are many papers submitted. The number of papers has been submitted. The speed is, growing so fast, and then there are not so enough reviewer pool, and as a result, some people, including maybe me, are feeling that the quality of reviews are getting worse than before. And so I really appreciate your research, which is rooted from your experience from the ACL president, I guess. So from that point of view, I think the big factor here is that the number of papers submitted is still growing really fast. So the scalability might be a big problem. So do you have any comment on when is it going to be will we get some plateau at some point, or is now we have some ChatGPT or writing assistant as well, so might be encourage or increase the number of papers. So I just would like to know your point of view. How do you think about it?
Yeah, I think this is a general problem, not only in NLP, but in all machine learning related fields. So the number of submissions is growing very fast, and also the number of people joining the field with little experience in the field is growing very fast. So that's why I have emphasized training junior reviewers as one major goal of this whole endeavor. I think complementarily, the reviewing culture is changing. While NLP originally comes from computational linguistics, that is a humanities-rooted field, right? So writing reviews has been a big value. Writing good text for review has been a big value. However, in computer science and machine learning, writing a text maybe is less of a value. And the reviews are getting more kind of short and more reduced to the actual argument. So it's not only the size of the community and the number of papers, but also the cultural change. And I know that many people do not like the idea of using AI, and specifically large language model, as a replacement for reviewers, because then the intellectual component of the whole story is lost in the process, right? And I think we need to understand good uses of AI and bad uses of AI, and the human should always remain responsible for the content. And I think this question is not trivial at all, because if you have ever tried to post-edit a review produced automatically to make a good review out of it, it's a very hard expert task for which people need to be trained. So I think that there is a very big scope for research of various kinds in this domain that needs to be addressed in the coming years. And I do expect that the number of papers will still be increasing, because the field is diversifying. So we not only now have technical papers, but a lot of papers about various kinds of applications of large language models in all areas of life you can imagine. So, but I think, in other fields like physics or psychology that exist for many years, they are very, very large, and they do function. Maybe the reviewing culture will need to be adapted to this new situation. And I do think that by all means, we need tools to support training new reviewers, because we just need more people to handle this process. If we assume that there is final responsibility always remains with the human.
Great. Yeah, thank you so much. Any other questions from the audience? Oh, okay.
So I was thinking about this task that you're trying to solve, and it seems like something from recent literature that might be relevant is the work on agents, because it sounds like this sort of task needs sort of step-by-step reasoning, right, and following links in papers, and maybe taking several tries to sort of refine the reviews. Have you had any research around that sort of direction?
So the last project I mentioned from the 4 projects that we have recently started is human-AI collaboration on writing. So in our case, we consider writing-related work as our use case, but in general, this is an instance of a more general scientific writing task by human and AI. And we do study the work on LLM agents in this context. Yeah, because I think the core question is how to split the work effectively among LLMs and humans. It may be like a teamwork. It's not only one LLM and one human, but there might be multiple humans and multiple LLMs. So how do we split the work that is a complex task or complex workflow in micro tasks, and how we put the results together? And I think this is very challenging because it also depends on the particular LLM and the particular human and their skills, because it's not static. You know, a junior reviewer has a different set of skills as an expert reviewer, or also LLMs might have different skills, right? And I think the work on LLM agents and agent collaboration is a very important theoretical and methodological foundation here. It's absolutely correct.
Right. Yeah, thank you. Do we have a little more time, or should we wrap up? Okay. Maybe Inui-san raised his hand. Maybe the last question. Yeah.
Hello, Iryna. This is Kentaro. Thank you very much for your great talk. It was really inspiring as always. Thank you. And I really appreciate your tremendous efforts for making this data set available, accessible to the community. I'm particularly interested in what you called long scope revisions, and the collection of such data is really valuable. So you sort of presented a demonstration of how that sort of data set could be used in the study for rebuttal generation, right? But you didn't sort of present anything about how that data set could be used for I don't know, the task of the long-term revisions. Maybe that could be even harder than the sort of generation of rebuttals. Do you have any ideas or any plans for that? Or thank you.
Yes, we do. Yes, thank you very much for this question. So our vision is that we can assist the revision process of papers in various ways. For example, one thing which is urgently needed, I guess, if a paper is revised between 2 versions, sort of like a summary of revisions that will help the reviewer or action editor to gain an overview of the changes made. For example, right now, we have the reviews, we have the camera ready version, but we don't know which changes have been made. And one application is to generate editorial notes. We actually have some data from this F1000 platform because they do have editorial notes that can be used as training data, and we are working in this direction. And also, well, ultimately, we also want to assist the author in making the revision. For this, we need to link the comments in the review and the revisions that have been made, and we maybe need to evaluate the sufficiency of the revision, the quality of the revision. We also can make suggestions how to revise the paper. So there are various applications that require in the next step this cross-document linking between different versions of the same paper and the review. And we are just starting some follow-up work based on this, but some pilot results and ideas are already discussed in the EMNLP paper. I could not go into detail of that in my talk, but if you're interested, you will already find some elaboration and the results of some pilot experiments there, and more work on this is ongoing.
Brilliant. Thank you very much.
Right.
You're welcome.
Okay. Yeah, right. Thank you for the talk. So let's thank the speaker again.
Thank you very much. It was my pleasure to be together with you today. Wish you a nice event. Bye-bye.
Bye. Thank you. Have a great day.